Good morning and welcome to today's AWS Masterclass webinar. My name's Ryan and I'm going to be your host today and take you through some content related to application services and dynamic dashboards, which is a grand title, and we'll dive into that shortly. So today's session is a masterclass, and this is a series designed to do a bit of a deep dive beyond some of the basics that you might come across on other Journey Through the Cloud webinars that we do. Help you educate you on some of the ways to get the best from AWS technologies and services, show you how some of the things work, and hopefully in 45 minutes or so broaden your knowledge and teach you some things that you didn't know before. And this webinar is titled Application Services and Dynamic Dashboard. So it's a bit of a grand title for really what I put together a demonstration system that ties together some of the services inside AWS to demonstrate how they can be used and how they can be used quite effectively. And the core of what we're going to show you today, or talk you through today, is services SNS and SQS to carry some core AWS events and then use those things to drive a web view across those AWS events, using S3 at the back end as a web server to host some dynamically generated content. So why are we doing this, and why am I putting together this sort of demonstration? It's really to show you some tips and tricks about ways in which you can use some of the services in differing ways, so it's beyond simple compute and storage. So what services am I going to talk you through today and touch upon? We're going to talk about EC2 because we're going to launch some EC2 instances, or talk about the events that we can generate out of auto-scaling that will surround some EC2 instances. We're going to touch SNS, the simple notification service, and SQS, the simple queue service, to publish some events, to persist those events on a queue. And then we're going to touch upon DynamoDB for storing that data, S3 for generating some or hosting some web content. And at the end of this, I'll talk through a CloudFormation template which you can download yourself, and then you can build this entire application after the event. So what's this application going to do? Basically, we're going to mimic an application, an arbitrary application that implements auto-scaling. So we're going to have an auto-scaling group as the basis for what we're going to monitor, and then we're going to trap, transport and store the scaling events that are produced when we force an action on that auto-scaling group, such as terminate some instances or increase the capacity of that auto-scaling pool. And I'm going to use a simple technique to produce some pseudo-dynamic content from S3, some little JSON files and some JavaScript in a web page that ultimately produces a dashboard. So it's an exercise, as I said before, beyond basic compute and storage. Now you can view a movie of everything I'm going to talk you through today in these slides, and I'll show this link again at the end, but you might want to take note. It's a short 10-12 minute movie of me actually building this system live and showing you in action, and all the assets that you're going to see today you can download yourself, and you can do this yourself in your account through a CloudFormation template which I'll share with you at the end. And this is a demonstration that's just an illustration of what you can do. So by no means am I suggesting that this is how you build dashboards in AWS. This is just an example of tying together some of the application services to give you some ideas on how you might use these things as well to glue your systems together. So what is it we're going to walk through? I'm going to build something in this way. We're going to have an arbitrary application in an auto-scaling group. So shown here, I've got two instances running some application. It could be a web application, it could be a SharePoint site, it could be anything really that is running on EC2 as part of a scaling group to implement elastic capacity. And we're going to trap the events that come out of an auto-scaling group via SNS to publish those events as a piece of JSON and then persist those events in an SQS queue, so that when an auto-scaling action occurs, we'll be publishing some data, persisting it so that we can do something with that at another point in time. We're going to also have a monitoring application, a simple script running on a monitoring server that will take that message from the queue. It will write that data to a DynamoDB table, and it will also form up into S3 a piece of data text file that can be read then by a web application served out of S3. So a really simple process, and you can replace, if you like, anything in that auto-scaling group on the left, and you could potentially take the simple script I have here running that you can download, and you could implement a monitoring dashboard to look at what's happening inside your auto-scaling groups. Now the simple script will be a Python script, and I'll talk you through some of the basics in there so you can get familiar with some of the APIs around SQS, DynamoDB and S3. But it's basically going to read the SQS queue and generate some data for S3. And then S3 has some static content, HTML, JavaScript and CSS, and then it'll read that data file that we're going to pop out into S3 bucket from the client browser, and ultimately forming up our tables of a dashboard that will look something like this. So this is served from S3 with data dynamically grabbed out of that same S3 bucket on a periodic refresh, showing the instances that I have in service and instances that have terminated in my auto-scaling group that's being monitored. So we can see instance IDs, the AMIs that's come from, the availability zone that it's running in, the public IP, DNS and so on and so forth. And so a very simple view, but showing us in green active instances and red terminated instances. So the glue behind all of this, and really the core essence of why I wanted to do this masterclass today, is to really open the lid on SNS and SQS as some essential glues between applications and between the services and components you might build on AWS. So SNS, the simple notification service, is simple by nature, simple in name really. It's really built around three core API calls at the top there: create topic, subscribe and publish. So it's a pub-sub framework where the messages that you publish are reliably and redundantly stored across an AWS region. It's scalable, it scales to an unlimited number of messages, and you can create subscriptions against your topics that you create within SNS. Different protocols, so it's flexible. You can receive these things over HTTP, you can receive data over email, you can pop messages in SQS queues. And it's integrated into a whole load of different services so that you can generate SNS notifications out of EC2, CloudWatch, and auto-scaling is what we're going to look at today. And then you can put a security model across the top of SNS so that you can ensure that only the authenticated people can read messages on these topics. Within the console, SNS has got a very simple interface. So a topic is the core component here. So you're going to generate messages and publish them to a topic, and then somebody can subscribe to that topic. So here I'm showing creating an example topic, which is my generic topic for messages. And flipping through the console, once I've created that topic, I'm then able to create a subscription against it. So here an example topic, and I create a new subscription. Then I can choose the protocol over which I will receive these messages when messages are published to this topic. So in this case I'm choosing an Amazon SQS queue, but it could just easily be poking an HTTP or HTTPS endpoint, something that you have running. You could be receiving data formatted in an email, or you could be receiving JSON in an email that you might want to then pull out of an inbox and process in some way. But Amazon SQS is what we're going to use, and commonly these are tied together so that the events can be persisted, and at some point in the future you can then read those events for processing. Now one of the things that you can do, and just by illustration, is you can tie this stuff together with CloudWatch. So here is a simple CloudWatch alarm, the create alarm wizard. So I'm creating here a CPU utilization alarm on a particular instance. So when the CPU utilization is greater than or equal to 65% for a period of 5 minutes, then this alarm would trigger. And in that create alarm wizard, I can then step through the action that will be taken when the alarm fires. So in this case, when this alarm is in state alarm, I'm going to take the action send a notification, and then I can choose what that notification will do. You could create an email topic in CloudWatch, which is a common thing to do, but that an example topic that I created in SNS will be available here as something to publish this event to. So that when this CloudWatch alarm fires, it will publish the topic of a high CPU, it will publish the message to the topic when the CPU is over 65%. So we can see here that I've got a CloudWatch alarm that will publish an SNS message that will be persisted onto SQS. So effectively with a few clicks of a mouse, I've trapped all my CloudWatch events or alarms, and I can publish them and I can persist them, and then I can read them off the queue and do something with them later. So that brings us nicely onto the second sort of glue service, which is the simple queue service. Again, it's very simple in terms of the APIs that you can access it through. So pretty much for things to note, creating a queue to actually create the logical queue that will persist messages across an AWS region. You can send messages to that queue, you can receive messages from a queue, and then you can remove messages from a queue. It's scalable, so SQS is designed for an unlimited number of processes reading an unlimited number of messages. So there isn't any cap on terms of the queue. So very good where you might be struggling to persist messages and understand disk requirements maybe for running your JMS persistence behind the JMS provider. SQS can take away all that capacity planning. It's reliable. When you put a message in a queue, it's stored across availability zones in the region within AWS where the queue has been set up. And it's very cheap, it's secure, you've got authentication mechanisms across the top, and it's very performant as well. So some people even buffer a DynamoDB table right via SQS so that when their Dynamo capacity isn't great enough from a provisioned perspective, SQS can buffer the messages. So it's performant enough to work in that regard. And the way that things works, and illustrating it via the Boto Python API for AWS, is that you have an application A, and you wish to publish some messages to a queue. So the first thing you can do is you can connect to SQS and then create a queue. And this simple call will then create that queue and make it available within AWS. You can then put a message on said queue. So simply here importing a message class, creating the message, setting the body, and then writing that message to our queue. Then a second application can read messages from a queue. And when you read messages from an SQS queue, you set the message visibility time. And here I have set a read with a message visibility of 60 seconds. And what will happen is that when you read messages from a queue, they will be made invisible to all other people reading that queue until that timeout occurs or the application processes them in some way. So typically you're going to set the message visibility timeout, you're going to read the message, consume it, and then you're going to delete the message, and then that message is consumed and gone. If I don't delete that message in that time, that message will become available for other readers of that queue. And when you dive into the SQS console and have a look at some of these things, and the demonstration video that I showed you or gave you a link for earlier on YouTube shows you doing this, you can read SQS queues from within the console. And again, you would set a message visibility timeout in the console so that those messages are now available for you in the console and no other subscribers to the queue can read them. So the core trick then of tying these things together for the purposes of building a dashboard is to tie auto-scaling event notifications published to SNS and then persisting those SNS by subscribing to that SNS topic from SQS. So we're going to move auto-scaling events through SNS PubSub backbone and then persist those events in SQS. And you can do this really from anything to anything. And I've just shown here the example, or talking through the example of trapping auto-scaling events. But these could be any events that you're publishing, with one simple publish message call to SNS, persist those in an SQS queue, and then have some other application consuming them for any sorts of business process that you might want to implement in your apps. So when we create an auto-scaling setup, the first thing we need to do is create a launch configuration. So a launch configuration here as a CLI tool is basically the EC2 AMI ID that you're going to create an instance from. The type of instance, here at T1 Micro, could be any of the families of instances that we have, security group to launch this instance into, and a name for this config. So this is the template for launching EC2 instances under autoscaling. Second part of autoscaling is to create a group. So a group which is using that launch configuration has some size, a minimum of 1 EC2 instance, a max of 20 across maybe a list of availability zones. Now they're the two core essences of creating an auto-scaling group. Now you can add the policies which can then be driven off CloudWatch, but for this demonstration and in part of the video you'll see the auto-scaling group is actually created by a CloudFormation template and it doesn't have any policies on it. But what we're going to do is attach an SNS notification. Now when you create an SNS notification, in fact when you create anything in AWS, everything has an Amazon resource name, an ARN. And we can see here an example topic had a topic ARN there highlighted. That's its unique identifier. So I can use that ARN in order to put a notification on my auto-scaling group. So the third command at the command line that I could do by hand is to AS put notification configuration against my auto-scaling group, and then bang in the topic ARN from my SNS topic. Now I can then also generate events of different notification types. And here I've got auto-scaling instance launch and an auto-scaling instance terminate. And you can run a command at the command line that will just describe those notification types that are available to you under auto-scaling. And there are 4 that you can choose from: instance launch, error, terminate, and terminate error. So I could produce those events, but this command is just going to look at launch and terminates. And then, like I did before, I can create a subscription to this SNS topic, Amazon SQS being my endpoint, and I would then give the endpoint queue Amazon resource name for that queue in this particular wizard. And then any of those auto-scaling events would then get published onto this queue. Now the payload that's produced out of these events is JSON, and here I've sort of truncated some of it, but to give you an idea. So we have a message type, and messages have IDs. Is being published to the topic ARN that we chose before, has a subject that's generated. In this case, this is a subject of auto-scaling termination for a group around my SNS dashboard auto-scaling group. Timestamps, signatures, versions, and URLs and so on for unsubscribing to these, because these could be sent via email, in which case people can unsubscribe to these notifications too. But the core part of it is the message, and messages, here I've taken a raw dump of the message from SQS being produced, but we can see the event is an EC2 instance terminate from my auto-scaling group, and then we got some prose at the bottom there of why this event was generated, and this is all coming out of the box, out of the SNS notification from the auto-scaling group. And here it's because I've explicitly set the desired capacity on an auto-scaling group from 5 to 1. So this instance in this case was taken out of service. So were other instances. Now that template is available to create that entire setup in CloudFormation. And you can download from Bootstrapping Assets, my S3 bucket. Again, these links will be available at the end of this presentation. But you can download this AS Register Instances template, and it was a CloudFormation template that creates everything I've just described. It will create the auto-scaling group to monitor, it will create the queues, the topics, tie them all together, and it will also enable you to create a monitoring application that we'll come on to later. But if you think about CloudFormation, all we're doing there is exactly the same. We're creating that auto-scaling group, we're generating notifications to a topic in SNS, and then we're creating a subscription to an SQS queue. And I've shown you the command line examples of tying those together, but within CloudFormation it looks pretty similar. So here I have a notification configuration on my auto-scaling group, adding those notifications around the events of instance launch and instance terminates. Just like my AS put notification configuration, this little block of CloudFormation template does the same job. Likewise, a subscription, as I've shown you in the console previously, can be created against that notification. So here I'm creating a subscription to a topic on the protocol SQS. So this is how I can then persist those events down onto my queues. So this is part of a larger CloudFormation template, and you can feel free to pick that apart. But you'll see that these things link together in a sequence of events to generate this system in a couple of minutes. So in principle, we've trapped some events. We've used SNS to publish them to a topic, and then we've got a subscriber, in this case just one subscriber, to persist those in SQS queues. So let's do something with those events. So the setup we've got so far is SNS notifications into SQS to persist it, and then I want to create an application that's going to read that SQS queue and then take the data and pass it into DynamoDB. So this is my monitoring application, and this is a little Python application I'm going to walk through how it works and how you can achieve similar things against the Botto APIs. That application is also going to take that data and form it up into some file to place into S3, and that application is then going to be able to be read by a browser, served as static content from S3, and then there'll be a JavaScript process that pulls the dynamic data in and forms up a dashboard. So this application, read messages from SQS queues, write the data to a DynamoDB table so that we can persist it and read it later and query it in different ways. We're going to form a JSON file from updated results, which is pretty simple to do because all the event data is already in a JSON format. DynamoDB, we can stick data in as a JSON format, and then we can write that file onto S3, which a piece of JavaScript is going to interpret. So this script is also available at that same bucket, and it's called asnodemanager.py. And this is all downloaded and bootstrapped as part of the CloudFormation template if you wish to use that. And again, I talk you through all of this in the demonstration video that you can Google after this webinar. So reading an SQS queue, how do we do that? Very simple in Boto, and the other languages and SDKs are just as simple in their constructs. First thing you need to do is connect to a queue. So here I've got a Boto connect to SQS. I'm going to specify the queue name that I'm going to connect to, and I'm going to set the message class reading as being a raw message. I want to get the raw content out of this SQS queue. Then I'm going to request some messages from the queue. Here I'm going to try and get batches of 10 messages, and then I'm going to loop through these messages and effectively switch on two things: the different types of event that's contained within my message. So an auto-scaling instance launch or an auto-scaling terminate. And in each case I'm going to do a different method call here to write to DynamoDB. So I'm either going to create a row in DynamoDB, or I'm going to update a row to set this instance to be terminated. And then once I've read the message, I can then delete the message. That will remove it from the queue. If I didn't do this, then the message visibility timeout I mentioned earlier would kick back in, and that message could be reread by any other process or next iteration of this get from the queue. Next thing to do is to write to DynamoDB. Again, it's just as simple in Boto to do this. So I'm going to get, in this case, save an instance on a scale-up action. So I'm going to get an instance ID from my message data that I pulled from SQS. I'm going to connect to my DynamoDB table, and then I'm going to insert a new item into DynamoDB. So DynamoDB is schemaless, so the only thing that I need here is a key, and this I'm going to use the instance ID as the key. And then the data that I put into this item or this row within the DynamoDB table is going to be a piece of JSON that's formed up here. So these are my item fields, if you like. Now each row could be completely different in terms of its structure, but the console neatly picks these things apart, and I'll show you a screenshot in a second. So once I've formed up the data to write, I then simply put the data to Dynamo, and I'll get a transactional write to Dynamo. So within the console, if you go to the DynamoDB table, you can browse content. And just to show you how this has been picked apart, so my instance ID there is my hash key, and it's my main sort of searchable attribute there. The rest of that data is that block of JSON that's been written in there, and it's being pulled apart by the console so we can see these individual fields. So the AMI ID, the availability zone, and so on, which match the fields that we've been displaying on our dashboard. A scaled down event done in a similar sort of way, and this is really updating a row within a DynamoDB table. So again, I connect to my DynamoDB table, I then update a particular attribute, a flag here to say that this instance was terminated, and I update the item. And ultimately in the browser then I can see my terminated flag for this particular instance flips to true. Then I'm going to write to S3. So S3 in our case is going to hold various different assets. And to get my core data asset out there, a piece of JSON, a couple of commands is all that's needed. So connecting to my S3 bucket that's been created where I'm hosting this stuff, and then I'm going to kick out a piece of data, a text file in JSON format into that bucket with a known file type. Now that data looks like this. very similar to the data that's been written to DynamoDB, and a different, just unpacked form really of the original SNS message, so pulling some stuff around the instance in, looking at the terminated flags and so on. So there are two instances that are written out into something, a text file in the purpose of this demonstration called instances.txt in S3. So now we have the data in S3, we can build a web view on it. Now S3 is a static web server, it's not an application server, it cannot generate dynamic content or process server-side scripts for generating dynamic content, but we can use a neat little trick here really and rely upon some client-side processing and some JavaScript. So we can build a web view essentially by having two elements in our S3 bucket. So we're depositing from that little monitoring app that I've just walked you through instances.txt. So this is a text file with that JSON with all the different instance events coming and going formed up within. Then in that same bucket I have some HTML, some style sheets and some JavaScript. And when we browse to that particular web page that's hosted in S3, we'll load it from S3 and we'll have a periodic refresh of that page to constantly go back to S3 to grab my instances.txt. And we'll use jQuery functions here to grab that data asynchronously and then use jQuery selectors to form up some tables in that web browser to form the dashboard that I showed you earlier. So the S3 bucket contains some folders for CSS, image, JavaScript, index.html is our core, and our instances.txt. Instances.txt is some JSON data, and then we use jQuery getJSON to go and grab that as an AJAX call. So the JavaScript functions an index page hosted in S3, pulled up to your browser, executing jQuery to do an AJAX get of the instances JSON in S3, pull it back, and then that data can be picked apart really easily within JavaScript. Using some jQuery table selectors, modifiers, etc., we can then form up a table view of instances that are terminated, instances that are currently running, and have that as a neat little dashboard that you've seen earlier. So the dashboard view here, that's exactly that. Here is showing one instance running and all my previous terminated. And you can build this again by downloading the CloudFormation template that I'll show you again, a link at the end of this, and you can follow through me building this in the video that I've mentioned. And you'll see this is on a periodic refresh of 10 seconds or so, and it's constantly looking to see if there's any new data being updated in that instances.txt. So effectively using S3 to generate some dynamic looking web application. So a really simple and quick way of doing some dynamic stuff on top of S3. So as I said, you can try this yourself. So again, this link will be shown at the end, but there's a YouTube URL that has a video. It's about 12 minutes long of me using the CloudFormation template shown below in my bootstrapping assets .s3.amazonaws.com bucket. So you can grab that template, you can then load it up into CloudFormation in the console, and you can run that template and it'll create all the resources that I've talked about here today. And the CloudFormation template itself runs through a number of actions required to create this demonstration. One is it creates the security groups required for different servers, so some security groups for my instances in an auto-scaling group that I want to monitor, security groups for my monitoring application and where it can read and write from and so on. Creates that notification in SNS and creates a subscription for SQS to that notification. It creates the SQS queue that we're going to subscribe to SNS from. It's going to create auto-scaling groups, launch configs. So it creates two of these. It creates one for the application under monitoring, a sudo, it's just an EC2 instance that you can then initiate terminates against or launches against. But it also creates one that bootstraps the monitoring application. It creates S3 bucket, it creates DynamoDB table, it starts all these instances up and gets you up and running within about 3 or 4 minutes. So do encourage you to have a go at that and have a look at that CloudFormation template. So in summary, as a short sort of webinar today, this is really just trying to bring up the fact that it's more than compute and storage in AWS. There are supplementary services that are really core and essential to building modern apps. and looked at pub-sub models with simple notification service, and then the reliable delivery point-to-point model with SQS, and how these can be simply tied together. So both of those services are really cost effective, they're highly scalable, they're reliable, and you can do simple things just persisting your CloudWatch events to doing inter-application, pub-sub kind of models with a persistent backbone when you put those things together. We've looked at some tips and tricks on how you can use S3 to produce some pseudo-dynamic content. And I've also touched upon DynamoDB as a NoSQL key value store, essentially, where the value part of that key is a JSON block, and how you can look at the tables within the DynamoDB table explorer within the console. So hopefully given you some ideas, introduced you to some handy services, SNS and SQS. And when you go and download that CloudFormation template, hopefully it'll give you some ideas on how you can use that to produce these dynamic multi-part systems with quite some elegance. So once again, view the video at the YouTube link shown there. So what you do after this for the next 10 minutes is have a look at that video, see exactly what I've been talking about in action. You'll be able to then download those CloudFormation templates, you'll be able to do the system yourself, you'll be able to pull it apart, and hopefully then you'll be able to take some of those patterns and use them, or come across a problem space in the future, you'll have a reference point in order to be able to solve it. So as ever, find out more at aws.amazon.com. Thanks very much for tuning into this webinar today, and have a good day.